Hello and welcome to week 11. This week we'll be looking at the different types of indicators that can be used to measure resilience in socio-ecological systems with the aid of the EcoFire case study. The use of resilience indicators is an emerging field and of critical relevance to the successful adaptive management strategies aimed at improving sustainability within complex adaptive socio-ecological systems. Indicators can be any output of a system, and a well-selected indicator can provide critical information on how well the system components are functioning and provide a timely opportunity to respond before a tipping point or threshold has been reached. We all use indicators daily. For example, the fuel gauge will help you decide when to stop for fuel and how far you can afford to travel. Governments and private industries likewise use indicators to monitor and respond to socio-ecological systems. The choice of both the indicator and the framework in which it is used can have significant impact upon the ability of the organisation to understand, respond, and predict changes within complex adaptive systems. Useful sustainability indicators should be scientifically relevant and measurable, comprised of components of a feedback mechanism that demonstrates the relationship between the system's components. Effective indicators for complex adaptive systems should be easy to understand for the general community and multidisciplinary teams, reducing the likelihood of communication barriers. Sustainable indicators are more successful when they pertain to a desirable attribute of the system. And lastly, and most importantly, indicators should be predictive of a future state and not merely detect something that has already happened. Once a desirable indicator has been selected, organisations must have a framework to understand how the indicator is relevant to the system and the corresponding management strategies. Here we'll examine 3 indicator frameworks in relation to the EcoFire case study. The EcoFire case study is an excellent example of how failing to recognise human involvement in the ecosystem is detrimental. It was assumed that low anthropogenic activity in the Kimberley area would lead to an improvement in ecosystem health. However, this was not the case. Following the cessation of indigenous fire regimes in the tropical savanna ecosystem, fuel loads built up over the wet season, resulting in extreme wildfires during the dry season. The scale and intensity of the fires caused significant ecological and economic damage in the area, leading the community to establish a multi-tenured project and to reinstate the equivalent of an indigenous fire regime. This case study is a clear example for the use of the pressure state response framework, which is effective and widely used by policymakers and managers. The PSR assumes that human activities, pressures, cause changes in the quality and quantity of ecological systems, state, triggering a response from within the socio-ecological system. One of the main advantages of a PSR model is that the selection of indicators can be done in a systematic manner, and the data acquired is generally well accepted within scientific and government organisations. The logical and widely accepted PSR framework likely contributed to the success of the EcoFire project by unifying a large and diverse project stakeholder group. The PSR system is easily adaptable and scalable to different disciplines. However, this is also a weakness, as oversimplification can result in underestimation of complexity. Knowledge gaps can have a significant impact on the reliability of PSR indicator selection, and poorly selected indicators can render the entire system ineffective. For example, using an indicator which corresponds to a fast variable is unlikely to be beneficial to adaptive management strategy. The EcoFire project used satellite fire scars and vegetation age as the main indicators, which, while successful in measuring the impact of the reintroduction of fire regimes, it did not provide a true measure of sustainability within the system, as these indicators failed to measure the socio-economic sustainability within the area. This is a common failing of the pressure state response indicator systems, as socio-economic pressures have a significant impact in system sustainability and are often not accounted for under these indicators. Community indicator programs offer an alternative to the more systematic PSR model by utilising community participants and resources to measure outputs in a specific region or area. Community indicators are generally aggregated statistics for a specific area and relate to social, economic and environmental issues. Community indicator programs are adaptable in terms of a bottom-up or bottom-down approach and are particularly good for filling in knowledge gaps in environmental management programs. Well-designed community indicator programs strengthen partnerships between community and managing organisations, resulting in well-aligned community experience and indicator data. Community indicator programs can be more sustainable than PSR models as they are often less politicised and reliant on funding. However, this can also be a weakness as access to specialists and consultants is comparatively lower. Additionally, data generated by community indicator programs is considered, rightly or wrongly, less reliable than PSR data, as community indicator programs comparatively lack the quality assurance, structure and consistency of PSR programs and are vulnerable to poor indicator selection. Integrated indicators utilise data from many different sources to generate a dashboard view of the state of the system. One of the main benefits of integrated indicators, for example, the ecological footprint analysis, is the ability to capture complexity from different areas of the system to better understand relationships of the system components. Integrated indicators can measure sustainability of the current state of the system to provide the required gap analysis information for environmental management programs, thus promoting data-driven solutions. While this indicator type can be very successful on any scale, poorly selected or summarised data can result in significant misinterpretations and poor understanding of system interaction. Incorporating community indicator programs and integrated indicators into the management of the EcoFire project would further the understanding of the system and provide the opportunity to look forward into the future rather than simply respond to the current state.